standard test method for flow of hydraulic cement mortar. This test method covers the determination of flow of hydraulic cement mortars. This test method is intended to be used to determine the flow of hydraulic cement mortars and of mortars containing cementitious materials other than hydraulic cements. While flow is not usually included in hydraulic cement specifications, it is commonly used in standard tests that require the mortar to have a water content that provides a specific flow level. The apparatus for this test method are flow table, flow mold, caliper, tamper, trowel, straight edge, cement, and water.
Procedure. So the first thing to do is to prepare the cement mortar. Next thing is clean the equipment by thoroughly wiping the flow table clean and dry, ensuring no debris or moisture is left on the surface. Next step is place the mold. Place the mold by positioning the flow mold at the center of the flow table. Add the first layer of mortar. Place a layer of mortar approximately 25 mm or 1 inch thick into the mold, and then tamp the mortar 20 times using the tamper to compact it evenly. Next step is add the second layer of mortar. Fill the mold completely with more mortar, and again tamp 20 times just as done for the first layer. Next step is level the surface. Use a straight edge or the edge of a trowel to strike off excess mortar. Use a sawing motion to level the top surface flush with the top of the mold. Next step is clean the table surface again. So wipe the flow table top clean and dry once more. Pay special attention to removing any water or residue around the mold. Next step is remove the mold. Wait exactly 1 minute after the mixing operation is complete. Gently lift the mold straight up, leaving the mortar on the table. Drop the table. Immediately drop the flow table 25 times within a span of 15 seconds. Last step is measure the mortar spread. Record each measurement in caliper divisions, estimated to 1/10 of a division. Calculation. So to get the flow percentage, we need to make use of this formula, which is the average diameter of mortar minus base diameter of mold divided by base diameter of mold, multiplied it by 100. Now for our average diameter of mortar, we got two values, which is 184.15 millimeters and 200.6 375 millimeters upper and down respectively. So in order to get the average value of this, we add both and divided by 2, and we got the value 195.26 millimeter as our average diameter of mortar. Applying it on the formula, we got the value of 108.48% and our base diameter of mold as 93.6625. For standard specification or limit and the specification. So if it's too dry or stiff, the specification for that is less than 105%. For too wet or fluid, the specification for that is greater than 115%. Conclusion and discussion. So the hydraulic cement mortar tested under ASTM C 1437 exhibited a flow percentage of 108.475%, so derived from an average spread diameter of 195.2625 mm after the standardized flow table procedure. So according to ASTM specification, mortar flow values are categorized as follows. Less than 105% indicates a mix that is too dry or too stiff. greater than 115% suggests excessive fluidity, and values between 105 and 115% represent an acceptable workability range. So the tested mortar flow of 108.475 falls comfortably within this ideal intermediate zone, signifying that the mixture possesses optimal consistency for construction application, neither overly rigid, which could hinder placement and compaction, nor excessively fluid, which might lead to segregation or reduced strength. So this result implies that the water-cement ratio and mix proportion are well balanced, ensuring suitability workability for practical use while maintaining structural integrity. For quality control purposes, such a flow value would typically require no adjustment, though minor refinements could be made if targeting specific performance criteria. So the outcome aligns with industry standards, confirming the mortar's readiness for application requiring reliable workability and durability.